This is an equation practice video. This one is on wave speed. The calculations are relatively simple. The issues will arise in waves with the units and the like kilo, nano, mega, stuff like that. So I'll give you the equation. So the wave speed is equal to frequency times wavelength. And the units, wave speed V is meters per second. Frequency is measured in hertz. Frequency is the amount of waves produced per second. And wavelength should always be measured in meters. Okay, so if you want to have a go at the questions, some of the units you might not be sure of, but it doesn't matter because I'll take you through the answers anyway and we could check. So I'm going to clear the screen. I want you to have a look at questions 1 and 2, and then I'll take you through the answers. So remember to pause at any point if you need to. So the first one, wavelength 8.81 meters, frequency 1850 hertz, and we're going to calculate the speed of the wave. So wave speed is equal to frequency times wavelength, and then we just need to simply put the numbers in. So the frequency is 1850 multiplied by wavelength 8.81 meters, and that gives us 16,298.5. We round it to 99. Speed is meters per second. Okay, let's look at number 2. So on this one, wave's got a wavelength of 720 millimeters and a frequency of 2.6 kilohertz. So we're calculating the speed of the wave again. So that's simply wave speed is frequency times wavelength. Frequency, remember, kilo is multiplied by 1,000, so 2.6 times 1,000 is 2,600. Multiplied by wavelength, millimeters, there are 1,000 millimeters in a meter, so you need to divide by 1,000, so 720 divided by 1,000 gives you 0.72, and then we need to times that by the 2,600. And that gives us a wave speed of 1,872 meters per second. Okay, if you want to go at the third one, then we'll have a look, a bit trickier. So on this one, we've got a wave, it's got a wavelength of 550 nm. Now, N means nano, and essentially that means divide by 1 billion, which is a 1 with 9 zeros. And then we've got the wave speed of 3 times 10 to the power of 8. If you're not sure about that notation, normally you would see it as 3 times 10 to the power of 8 meters per second. On a computer, depending, if you can use Microsoft equation, depending what you're using, you might have to write it as 3 times 10 to the power of 8 meters per second. But essentially they're the same thing. So if you wasn't sure about that, now you can pause and have a go. I'm going to take you through the answers anyway. So a wave is a wavelength of that, and calculate frequency. So a wave speed is frequency times wavelength. We need to get rid of the times lambda, the times wavelength, to get frequency on its own to make it the subject. So we need to divide on the other side. So wave speed divided by the wavelength gives us the frequency. So the wave speed is 3 times 10 to the 8, which I'm just going to write as 3 times 10 to the 8, divided by, and it's, you could do 550 divided by a billion and then put that number in, but I'm just going to simply write 550 times 10 to the power of minus 9, because that's the same as dividing by 550 billion, divided by a billion. So if you put that in your calculator, you should get 3 times 10 to the 8 divided by 550 times 10 to the power minus 9. You will get a frequency of 5.45 times 10 to the power of 14 hertz. That's what makes those questions tricky. It's not the maths, it's dealing with the standard form and the units. Okay, so let's do 2 more practice questions. All right, let's do 4 and 5. So if you want to pause and have a go. And then I'll take through the answers now. So we've got a wave of frequency 1.2 times 10 to the power of 15 hertz, and it's got a wave speed of 3 times 10 to the power of 5 kilometers per second. I have to be really careful with this one. So we want the wavelength. So the wave speed is equal to frequency times the wavelength. So wavelength, we just need to get rid of the times frequency. So we'll divide by frequency on the other side. So wave speed divided by frequency gives us the wavelength. And the wave speed, I like that. The wave speed is 3 times 10 to the power 5 kilometers. So we need to turn that into meters. So obviously there's 1,000 meters in a kilometer. So you need to do 3 times 10 to the power 5 times 1,000, which will give you the 3 times 10 to the power 8 meters per second, which is the speed of light, divided by the frequency, 1.2 times 10 to the power 15. So if you put that in your calculator, you will get a wavelength of, it should come out as 250 times 10 to the minus 9 meters, which is obviously really small. And you could also write, if you'd remembered about the nanometers, so because nano is times 10 to the power minus 9, you could also write 250 nanometers. Okay, let's look at number 5 then. So number 5, a wave is a wavelength of 40 millimeters and a frequency of 1770 mHz. Calculate the speed of the wave. So let's have a look at this one. So wave speed is frequency times wavelength. So the frequency is 1770 mega, remember, means million. So capital M means million, means mega. So you could times by a million, or you could simply write times 10 to the power 6, because a million is 6 zeros. So 1770 times 10 to the 6 hertz multiplied by the wavelength of 40 millimeters. And you could do 40 divided by 1,000 for that one, which would be 0.04. So you could do times 0.04. Or you could understand that millimeter means divided by 1,000, so you could write it in standard form as times 10 to the power minus 3. Either way, it's the same number, it's going to give you the same answer. So it's 1770 times 10 to the 6 multiplied by either 0.04 or 4 times 10 to the power minus 3. And it will give you the full number, 708,000 meters per second. Now, if you've got a scientific calculator, which you should have if you've been using standard form, there's a button on it, and it's normally above the number 8 on a Casio, and it's got ENG, and what that means is engineering. If you click that button, it will put it into the closest engineering prefix. So I've just pressed that now with that number in my calculator, and it gave me an answer of 7.08 times 10 to the power 6 meters per second. Now at GCSE, it won't matter which one you put, but you know, if you're moving on to A-level studies, the engineering button can be quite useful. Anyway, I hope you found that useful and that helped, and thanks for watching, and I'll speak to you soon.